Alrighty. So guys, this week, of course, we're getting into week 5. So we're kind of done halfway with this class. It's an 8-week class. We've done with the first 4 weeks. We're getting towards the last 4 weeks of our classes. And also remember, this is the week here onwards. You do not have any more discussion posts in D2L, nor any assignments or activities through D2L. So all the work that you will be doing this point onwards is going to be in my stat lab. So, your homework, quizzes, exam, like you've been doing. But, obviously, as you saw from last week, this is also where we have started combining chapters now. So, we're still working with the same topics when we're combining these chapters. And as I was kind of mentioning last time that, in some textbooks, this would be a single chapter. It's just your textbook is kind of breaking up, into 2 separate ones. So, again, don't get hung up on the fact that you're working on 2 different chapters. It's actually the same concept. It's just been broken down into, separate chapters. So we're still continuing our discussion about probabilities and probability distribution. But now, last week you guys looked at binomial probability distribution. Now we're getting into normal probability distribution this week. And you've actually done a little bit with normal probability distribution back in, I believe it was chapter 3. Yeah, chapter 3, where we talked about the empirical rule and we talked about the z-score. So you will see we're actually going to bring that exact same concept of empirical rule and z-scores, and that's where you're going to start. And then, of course, we'll get more in depth with the normal probability distribution in these chapters. So that's kind of where we are headed this week. So as you can see, of course, we've got our interactive session over here, and then your reading and viewing assignments. And then, of course, there are no learning activities, like I mentioned this week. So again, under your reading assignments, you will see that you have links to the textbook pages and you have links to the handouts that I have created. So definitely, I recommend you guys to go and look through that. And then under the viewing assignments, again, we've got our crash course statistics videos, and then you will see I've got video lectures from chapter 7 and 8. And again, you will see there is some videos over here on specific homework problems from my stat lab. So you can see these are from section 7.2, 7.4, and 8.1. So, if these are the same problems that say you think you might need additional help on, then, go and look through these videos over here. So all of this is going to be available under the view for week 5. The activity that we are actually going to be working on today is going to be related to normal distribution, since that's kind of what we are getting into. So let me go ahead and share this link with you. This is where the instructions are for the activity. So I'm going to send this link through our Zoom chat. You should see that coming through. So this will bring you to the activity itself where the instructions are. And let me actually make a copy of this. And this is where we will actually be working on. So let's make sure you guys are able to go in and type stuff in. Okay, and here's the second link that's coming through our Zoom chat. And this is going to be for the document where we're actually going to be doing our calculations and working through. So the first link is for the instructions page. The second link is for the document, the worksheet where we're actually going to be doing our calculation. So make sure you are in both of these files so you are able to work alongside, simultaneously. So this one here, we again just picked a simple example, and this is just to kind of highlight, how normal distribution can be used in, an application in everyday instances. So here, as you can see, we're talking about a factory makes bowling balls. that makes bowling balls is trying to make 15-pound balls. You know, that's their threshold. That's the weight limit they want. They have a shipment of 10,000 balls to send. Bowling balls that are less than 14.9 pounds will be considered too small to use. They want to make sure that they are making proper bowling balls, you know, without having to obviously test all 10,000 of them, because as you can imagine, you know, that will be time consuming, not to mention expensive, because you'll be pulling people away from, you know, what they normally do. And now they're sitting and, you know, weighing these bowling balls. So obviously that's not going to be practical. So they don't want to test all 10,000 of them. So assume that the weights of the bowling balls follow a normal distribution. They have randomly drawn 3 samples from those 10,000 bowling balls for testing. And here are those 3 samples. So you can see in each of the 3 samples, we have, what is that, 10 bowling balls that they have done. So you have a total of 30 samples here, but they're broken them down into, you know, groups of 3s. So based on these samples, determine if the factory is sending out a good shipment or not. Your decision needs to be made using Z values and, you know, the normal curve chart. Show your work and justify your reasoning. So that's kind of where we are going forward with this, is looking at these samples and coming up with, you know, our Z scores, and then we'll try and put this in a normal curve chart to try and see, you know, what our samples look like. So that's where this second document is coming into play. So as you can see, I've already got the weights listed over here for all the 3 samples. So you've got your sample 1, sample 2, sample 3. So we will need to, you know, calculate our Z scores. And on the right-hand side of this document, if you can see, I've got the definition or formula for the Z score. So you will see right over here on the right-hand side, you've got the Z score, which is the data value. And in this case, your data value will, of course, be the weight of the bowling ball. From that, you will be subtracting the mean and then dividing by standard deviation. And, you know, of course, we will be doing this for all 3 of our samples. So here the idea is, you know, first we need to start out by finding the mean for all of our, you know, the entire sample that we have over here. So again, remember, you can use the built-in functions to do that. And we talked about this in chapter 3, so hopefully you guys will remember that. Additionally, you will see I've also broken down our mean and standard deviation by each of the samples. So here in the center, you will see I'm also asking you to find the mean and standard deviation for each of the samples. And then we will be finding the mean and standard deviation for all 30 of our samples, right? So we'll be doing it for the entire data set, and then we're breaking down by the samples, because, you know, just again as a comparison to see what the sample mean and standard deviation looks like for each of the individual samples and what it looks like for all of them. So can you tell me, and actually some of this we are not going to find because that information is given to us. So going back to our document over here, can you tell me, what did I do? What our mean and standard deviation should be for these 10,000 balls that, you know, this company is manufacturing? What should our mean and standard deviation should be for the shipment of 10,000 bowling balls that we are shipping? Because that information is actually given to you here. Anybody? What are they telling us? What weight are we trying to go for?
$15.
Yeah, exactly. They want each bowling ball to be as close to 15 pounds as possible, right? That's our goal. We're making 15-pound balls. So that's actually going to be our mean for the entire data set. Now, what are they telling us about What other information are they telling us? Because that will help us find the standard deviation. So what will our standard deviation? And I already saw somebody was doing calculations on that page. Hold on for your calculations, because I'm actually going to put you in groups of 3, and each group will get 1 sample, and you'll be working on it together. So 10,000 balls would be, the size of our shipment, right? But how will that help us in determining what the standard deviation should be? So is that where, is that 10,000 going to make a difference in what our standard deviation will be? Because technically that's sort of your end value, right? What your size is. In this case, the 10,000 actually will represent our population because our sample, remember, we're only taking 30 bowling balls in those 3 samples. What are they telling us about the weight of the ball? Right over here, they're telling you bowling balls that are less than 14.9 pounds will be considered too small to use. So what will that make our standard deviation then? Oh, come on. Your goal is for 15 pounds. They are saying if the balls weigh less than 14.9, they will be considered too small. So what's that difference come out to be?
Would it be 0.1?
Yeah, very nice, 0.1. So that actually tells us, because think about it, if 14.9, if the balls weigh less than 14.9, then we are saying they're going to be too small. Well, in that same sense, and of course that's 15 minus 14.9, which will give you 0.1. In that same sense, you can think about if the balls are, heavier than 15.1, then obviously they will be too big also, right? Because you can't have too small, but then, if it's 15.2 pounds, you're good to go. No, because again, there's got to be a threshold for what can be considered too big. So that tells us that 0.1 is actually going to end up becoming our standard deviation in this case. So that's where, what happened to my values over here? Okay, not sure what happened. So 15 and 0.1 is what's going to be for your mean and standard deviation for the entire data set. And this is coming from our information that's given to us in the description itself. Now, this is what I'm going to do. I'm going to break you guys up into 3 groups, each group, and we'll do it this way. If you are room 1, you will work on sample 1. If you are room 2, you will work on sample 2. And if you are room 3, you will work on sample 3. How many of you do I have in here? I've got 9 of you here. So that will be 3 to each group. And then you guys will work together in calculating your z-scores. And again, like I showed you, the formula is right there on the document itself. So your z-scores are actually going to be based on 15 pound as your mean and 0.1 as your standard deviation. So for each of you, when you're calculating your z-scores for your sample sizes, use the original mean and standard deviation. However, I also want to know what is the mean and standard deviation just for your sample. So you will be like, for sample 1, you guys will be taking these 10 values and you will be calculating your mean and standard deviation. Same thing for sample 2, same thing for sample 3. We just want to see what the mean for each group is. But as far as z-scores go, remember, you are using these original calculations for mean and standard deviation, okay? And then once you guys are done with your z-score calculations, I'll bring everybody back to the main room. And then we'll compare answers. And then from there, I will show you how we can actually come up with that normal curve chart in Google Sheets. So give me a second here, and you should start seeing your breakout rooms invitation here in a minute. And I'll keep rotating between the groups just to make sure if you guys have any questions, I can answer them for you. So please remember you're working on this together as a team, and you should start seeing your invitations coming through now. Alrighty. Sorry about that, guys. For some reason in the middle, my Wi-Fi just shut down, and I'm logged in through my phone just in case it happens again. So that's why you're seeing a second screen with my name on it. So I see that you guys are done calculating your z-score for each one of your samples, and then you have your mean and standard deviation for each one of your, just your individual data set. So what I'd like you to do is just kind of looking at the z-scores for each of the samples or for each of the groups that you guys were broken down into. What does looking at the z-score tell you about? Are those bowling balls too heavy or too big or too small? Or are they within the limit that, as these people working at this factory, would you say your shipment is good to go? Or do we need to, kind of fix our process? Maybe the balls are coming out to be too big and too small. So how can we tell that looking at the z-scores if our samples are looking good or not, if they're within the weight limit or not? Because we know they cannot be too small. They cannot be less than 14.9 pounds. And on the reverse side, they cannot be bigger than, 15.1 pounds, right? They don't want to be heavier than that. So looking at each one of your individual samples, what can you say about, do you have a good sample or do you have balls in there that would not qualify? So looks like room one, Ali and Ian.
I don't know. It seems like it's pretty all right. We got
Mm-hmm.
115 in there. And
Yeah,
then
so
that
you,
0.99 is like pretty damn close, but I don't know if those balls would work.
so you're still within acceptable limits. Yeah, the one I would be concerned about is definitely that last one in your sample, the 15.1, because when you see a z-score of 1.00, that, remember, that means your standard deviation is right at 1, which means you're right at that threshold where you're just making the acceptable limit, right? If you were even slightly over 15.1 pounds, and remember that ball would have been too big. Same thing on the reverse side, if you would have been too less than 14.9. So, if you drop it below 14.9, so it could be like 14.89 something, right? You would be too small. So you guys are just making it within your threshold requirements in sample one. And then when we look at your mean and standard deviation, again, you can see you guys are, again, within acceptable limits because your mean, again, is not bigger than 15.1, but you are definitely a little bit slightly over 15 pounds. But, again, I would say in acceptable range. All right, very nice. Group 2, you guys were working on sample 2, and that was Blue, Caitlin, and Lourdes. What kind of conclusion can you draw about your data set over here? Caitlin, you think yours looks good?
I would agree with Caitlin and say that two of ours are, I think, pretty within, and we don't have anything over 1, just like Caitlin just said.
Yeah, so you guys actually have just a hint of a better sample set than group one did, because, like I said, their last ball was definitely a little bit that would be concerning because it was riding right at that threshold. But you guys have done really well of staying between 14.9 to 15.1. Even on the heavier side, your heaviest one is at 15.03. So, obviously quite a bit below that 15.1 threshold. And then looking at your mean and standard deviation, even if we just compare that with sample one, you guys are slightly less heavier than sample one. And, of course, the idea is these samples have to be random. So, whoever pulled the balls off the assembly line or, the factory floor should have done a good job of picking a random sample. So it shouldn't really affect what ball showed up in your sample size. But yeah, looking at sample two, it's definitely looking well within our range. So that's an acceptable data set. And then let's look at room three, group three. You guys worked on sample three, and that was Kit, Montserrat, and Rachel. What can you guys say about your data set here?
All of them were in the weight.
So that looks acceptable, right? Because again, you guys are going from 14.993 at the lower end to the 15.026. So you guys are actually slightly even better than groups 1 and 2, because again, your weight is again more concentrated towards that center. And I was looking at your mean earlier, and it looks like your group has the smallest mean out of the 3 sample sizes, because your guys are just at 15.005. So even just comparing the 3 samples, you can see our sample 1 was at slightly heavier. Again, nothing concerning, right? I mean, not to the point where we would be worried about our manufacturing process is incorrect. And then as we went down to sample 2 and then down to sample 3, those weights got better. But the idea behind picking these 3 samples in 3 different groupings was to basically see that, we were going to be in that acceptable weight limit. And if these 3 samples or these 30 bowling balls look good, then we can basically extrapolate that and say, our shipment of 10,000 is going to be good. And we don't have to worry about the balls being too small or too big, and we have a good shipment to send. So that's kind of where, this idea comes into play. Now, our next step is going to be creating our normal distribution chart, right? The normal curve. And I've kind of put some instructions over here. So if you were to, just hover your mouse on top of these, in these cells where you see that little corner black corner on that actually means you've got some note or information or a comment over there. So I've kind of included how we can come up with this. So traditionally, when we do a normal curve, and you may remember this from the empirical rule, or if you guys have read chapter 7, 8 at this point, you will have seen that, normally with normal distribution, we go 3 standard deviations below the mean and 3 standard deviations above the mean. So that's the policy we want to follow over here. So, again, our mean is 15. Our standard deviation is 0.1. So that's kind of the idea you want to use. And I've given you a starting formula there. So you can see this is going to be mean minus 3 times the standard deviation. So that's going to be the lowest value on our table. If you go to the bottom, we are going to mean plus 3 standard deviations above the mean. So that's going to be, our beginning and ending value over here. So again, you can just do equal to. I'm going to click on the cell where I have my mean minus 3 times the standard deviation. And again, I'm just going to click on that cell, and it's going to come out to be 14.7. For the other side where we want mean plus 3 times the standard deviation, again, I'm just going to click on mean plus 3 times the standard deviation. So now the idea is we know our smallest value has to be 14.70. The largest one has to be 15.30. Now these ones in the middle actually have to increase at a consistent level. in such a way that, you're going from 3 standard deviations below to 3 standard deviations above the mean in a constant increment, right? So you want to keep increasing by, 0.1, or you want to keep increasing by 0.2, or, whatever it seems, but have a good transition as you go from 14.70 to 15.3. So you can try and say, okay, I'm going to take my 14.70 and maybe increase it by, I don't know, 0.1. So 14.80, and, we can kind of take that and move it down. But you will see when we do that, we reach 15.30 kind of at the halfway mark. So even before we made it to the bottom of the table, you're already at 15.80. So this increment is not working out. So 0.1 is too large. So, reduce that by half. And instead of 0.1, we'll make it 0.75. So, you're increasing by 5 hundredths. And then let's see what happens when we bring it down. So you will see this was a good increment because we went from 1475, 80, 85, 90, 95, we get to 15, then 5, 10, 15, 20, 25, and 30. So that's the even increment that I'm talking about. So, that way you will get a nice smooth curve on your normal distribution. Now, this is a built-in function, the normal dot distribution, and this is going to actually help us calculate, the percentages, the weights that we need. So I've included the formula here in the comment, but I've also put it here on the top in this yellow cell. So here we're going to do norm dot distribution. So that's the built-in function we want to use. Then look at that. You click on your data cell, which in this case will represent the weight of 14.7. Then you're going to click on average, which is your mean of 15 pounds. And since that number is actually going to stay the same because our average is not going to change, I'm going to put that, again, with my dollar symbols on it. Then my standard deviation, of course, our standard deviation also for the entire day data set stays the same. So I'm going to put dollar symbols on that cell. And then the last value is always going to be false. So this will go ahead and calculate the set for us. There shouldn't really be anything over here. And you are able to get your, weight for the table. Now to graph this, I've put the instructions here in this little orange box. You're basically going to select this table that we just completed. So, using both columns for weight and normal distribution. And then basically you are going to go under insert, go to chart. And as you will see, I'm asking you to do a smooth line chart. So, by default, it's going to give it to you where it's kind of looks like you're almost connecting the dots, right? Because it has that little sharp corners to it. So that's why we need to change it to a smooth line chart. So it looks like a nice curve. Did I skip over it? There we go, smooth line chart. And you can see this looks a little bit more like what we see in our textbook, what a chart should look like. So I'm just going to move this guy down here. And, again, once you have this graph, it kind of helps you to see visually, what we're talking about in this particular example, where we're trying to stay between 1 standard deviation below and 1 standard deviation above. So we know our bowling balls cannot be lighter or smaller than 14.9, and on the heavier side, they cannot be bigger than 15.1. So that's our threshold. Of course, right in the center is where you have your mean. So basically, we are saying all the bowling balls that fall in this area over here are going to be acceptable for shipment. So all of these weights, are going to be okay. But as soon as you get into anything beyond that, so, here would be too small. And then of course, anything on this side would be too big. So that's kind of how, you are doing this. And this idea of normal distribution is used in so many different examples. I mean, even in your textbook, you will see they talk about, bags of chips. They can be those snack size bags that you have. They can be, the big family party size bags that you have, because all of them are weight oriented, right? There's a volume or a weight to your packing. So again, you want to stay within that threshold. So, if it's oh my Lord, let's say half a pound bag, right? So you don't want to go too low or too high. You can actually use the same idea with pumping fuel at the gas station, right? Because let's say if you're going for a 10-gallon fill up, well, you want to make sure you're as close to 10 gallons as possible, right? You don't want 10.5 gallons, but then you're paying for 10 gallons. Obviously that's not going to work. I'm sure none of us would complain if we got 10.5 gallons, but we only paid for 10, right? But we're going to be really, really mad if we're on the lower end of things. But as a business owner, you obviously want to make sure if somebody's paying for 10 gallons, they're not getting 10.5 gallons of fuel either, because that's a big loss. And as you can imagine, with the higher gas prices right now, every little drop is going to be valuable. So you will see on these, machines, your little pumps, that they actually have inspection stickers on there where they say when the machine was inspected. And that's actually what they do, is they check the machine for accuracy. So they have a, 0.01% threshold that, you can, if you're pumping 10 gallons, you can do 9.999 something, right? And you're going to be acceptable. On the other side, you can be 10.001 or something like that, and you would be acceptable. But you don't want to go beyond that. So they actually check to make sure that the pump is working efficiently, that accuracy is there, and you're not getting too little or too much. So all of this actually falls into this idea of how we can use normal distribution to come up with these, verifications, these accuracies and stuff. So you will see a lot of different examples. Of course, we talk about normal distribution in terms of, and you will see these examples in your homework, with weight, with height, tons of other examples, weather patterns, how much snowfall or rainfall you get in a year and all those kind of things. And, you will see how we can use these standard deviations. Are you 1 standard deviation away from the mean, 2 standard deviation away from. Now, you guys will, of course, have noticed that you have negative and positive z-scores, right? So the negative means you are below the mean. Positive means you are above the mean. So, 14.993 was a number smaller than 15. That's why you got a negative z-score. 15.001 was obviously greater than 15. So that's why you got a positive z-score. So the positive or negative is kind of working like more of a position. Are you below the mean or above the mean? Additionally, when you get something like, and let's go ahead, clear all of this out. When you see something like negative 0.07, remember that is also a standard deviation. That's just telling us you are 0.07 below the mean, so you are somewhere very close to the mean. Even the 14.999, where you have a z-score of negative 0.01, is going to be a hair away from the mean, but on the left-hand side, at 0.001, you are again just a hair, but on the right-hand side of the mean. So, that's kind of how these guys work out to be. So this is what you will be working on in your chapters 7, specifically 8. We will be getting a little bit more into sampling distributions. So you can kind of see, and I had just done, this as a checking sort of thing. So you can see, you can compare your answers to see, and, obviously you guys were pretty close to these values over here. This is just, just to kind of show you where all the little standard deviation markers fall. So these ones are actually halfway between. So this would actually be at, 14.9 7.5. This one in the middle here would be at 14.85. So these are just, kind of if you were going halfway between that. But like I was showing you earlier, a lot of times we only do, 3 to 1 standard deviation below the mean. This is, of course, the mu itself, and then 1, 2, and 3 standard deviations above the mean. But, obviously we can use those in between values also to do these, standard deviation calculations. So again, guys, this is what you will be working on this week is normal probability distribution and sampling distributions. I also wanted to remind you, because I've had a couple of you ask me this, we will be, this is chapter 7 and 8. You're going to have chapters 9 and 10, which is again going to be combined for next week. And then the week after that, you will actually be working on chapter 11, and we actually go back to chapter 4. So we're actually tying chapter 11 and chapter 4 together. And those are the smallest chapters you will be working on, because from chapter 11, you're only doing 1 section. From chapter 4, you will be doing 2 sections. It's actually only going to be 3 sections you're going to be working on. So that week, which actually falls during week 7, I will allow you to go back and work on any older homework. And yes, we do have finals. You will be working on older homework and quizzes. So during week 7, when you are working on chapter 11 and 4, since they happen to be a smaller chapter, I will actually go back and open up everything from chapter 1 through chapter 10. So that will be chapters 1, 2, 3, 5, 6, 7, 8, 9, and 10. So I will let you go back and work on any older homework, so if you want to bring up your grade, if you have quizzes, attempts left, remember you get 3 attempts on the quizzes. So if you have any attempts left, you can go back and work on the quiz to try and get a higher grade. And I will give you an opportunity to retake any one exam. So it can be an exam you missed. It can be an exam you got a score that you don't like on it and you want to try again. So that's up to you. So you can retake a missed exam. You can try and take an exam to get a better grade on it. I will obviously keep the higher grade. So, if you retake the exam and let's say you don't get a good score on it, you will get to keep the higher grade. So if the original grade was higher, you'll get to keep that. Additionally, after we're done with all of this, before you take your final exam, which will be during week 8, so that last Tuesday of our class, you guys will actually be coming in to take your final exam that morning. So your final exam has 2 versions. One of them is the in-class version, which is what you will be working with me. Just like you are on Zoom right now with me, you will stay on Zoom and basically just work at your end on your exam. Once you're done, you'll be able to leave Zoom. So that's an hour-long exam, just like our class time. And then you have a take-home version of the final also. So the final is broken up into 2 parts, because 1 hour is just not enough time that you can do, some of those longer questions with the multiple parts, multiple calculations. So those sort of problems will be on the take-home version. The final will be more like, simpler, smaller calculations, some of those terminology concept questions like you've been doing in your quizzes. So those kind of questions will be more on the in-class, with smaller calculation problems, and then the big long calculations will be the take-home version. So before you take the final exam, I will drop one of your, or whichever one is your lowest chapter exam. So this doesn't apply to the final. Out of the chapter exams you've taken, whichever one is your lowest score, so that can be a 0 if you've missed an exam, or that can be whatever is the lowest score, I will drop that. So the idea in doing this is that hopefully you can kind of bring up your overall grade in that last week when I reopened the older assignments. I would say finish working on chapters 11 and 4 first, get that out of the way, and then you can go back and work on anything older in my stat lab. And then, we take the final exam, and that pretty much wraps up the semester. So that's kind of what you are looking at as you're going forward. So and the reason I'm telling you this right now is my suggestion to you is, if you actually go ahead and stay on track for these remaining chapters, right? Get your homework done, take your quizzes, take your exam. Anything that in the first half of the course that you would like to redo, then you can use that week 7 to, redo whatever you want to do, go back and work on homework. take an exam again, or, whatever that might be. Because, if this second half, if you fall behind, and don't get caught up, then trying to catch up for 8 weeks or 7 weeks worth of stuff in 1 week is not going to be practical. So, you kind of have to kind of see, okay, if there's something in the past 4 weeks that I've done that I would like to redo, then that's my chance in week 7 to redo that. But, in week 5, week 6, week 7, if there's something you're falling behind on, plus something from the first 4 weeks, then, that's going to be a lot of things to catch up on. So, remember, you have a chance to sort of redo some things, but not everything. So you may want to kind of balance yourself out and see, okay, this is my class, this is what I need to do. And, again, guys, there's no shame if you feel like you are struggling, and you will not be successful in this class. It's okay to withdraw from the class also, because I don't want you to think of it as a failure or think of it as quitting, because getting a failing grade can be more detrimental than anything else. Because remember, it brings your GPA down, brings your GPA down, and bringing that GPA back up can be challenging, right? So it's better to take a withdrawal than take a failing grade. So just keep that in mind. Your last day to withdraw is April 27th, which falls on, what is that? A Wednesday next week. So you've got just, a little more than 1 week to kind of think about that. Talk to your academic advisor just to make sure withdrawing is an option available to you, because depending on, what your financial aid looks like, sometimes you're not able to withdraw. So before you withdraw, talk to your academic advisor just to make sure that's an option available to you. But like I said, it's okay if that's what you need to do. You can always come back in summer or fall, take the class again. If 8 weeks was too small time for you, take this as a 16-week class. We offer this as a 16-week class also. So I just wanted to kind of let you guys know what all options you have available, what's coming up. And I'm here to answer any questions to help you out. Also, remember, I have office hours on Mondays and Wednesdays from 5:30 to 6. If you want to come in and ask for help, if that time does not work, we can schedule a time that would work for all of us, or for both of us. And we can also, schedule a different time to meet. And if you have any questions, we can go over that. So you're not coming in person, Caitlin. We're actually meeting over Zoom like we do right now for class, but you will be on Zoom while you take the exam. So it's kind of like that, if I was in a classroom with you, we would be, taking the exam together. So that kind of thing, you will just stay on Zoom, but you will be working on the in-class. So that password, I will actually not be sending to you through email. You will come to class and I'll send you your password through the Zoom chat like I do our links and stuff. And then for the take-home version, like we normally do, you will email me and I'll send you the password for the take-home version. So that's kind of like our in-person exam, but not actually physically in person. We're still doing it over Zoom. Any other questions coming to mind, guys? Okay, alrighty. If you have any questions, please stay back. If not, I will see you next week. Good luck, everybody. Take care and have a wonderful day. Bye, everyone. Be careful. Stay
Thank
safe.
you.
Thank you. Bye-bye.